Welcome back to the Algebra 1 Unit 2 test review. We will be going over sections sections 5, 6, and 7 in this video. So let's get right into it. Write the equation of a line that has a slope, has a horizontal slope, and passes through 2, 5. So what we need to know is, what does horizontal mean? Well, horizontal means a line, this is horizontal. And so if it goes through the point 5, then the easy way to remember this is just going to be the equation is y equals 5. If you want to use y equals mx plus b, remember that a horizontal slope line, the slope is 0. And so you get y equals 0 times x plus b here. And if we plug in our values for x and y, plus b, we get 5 equals b. And once again, so we get y equals 5. Write the equation of a line that has a slope of 1/3 and passes through the point 6, 7. Most of you were taught to use y equals mx plus b again. So I'm going to plug in what I know. I know that this is m. I know that this is x. When this is x, this is y. So when y is -7, x is 6. And now I just need to solve for b. And I'll get -7 equals 2 plus b. I will subtract 2 from both sides, and I'll get b equals -9. So the equation of my line is y equals 1/3 x minus 9. For C, write the equation of the line in slope-intercept form with the given information. So y equals mx plus b. That's slope-intercept form. I need the slope, and I need the y-intercept. Well, the y-intercept is easy. That's -1. Then the slope is the rate of change. So we go down 2 and over 1. And that pattern keeps continuing. So the slope is -2 over 1, or simply -2. So my equation is y equals -2x minus 1. Y equals mx plus b. This is a vertical line. And just like 2 problems ago, we had a horizontal line where it was y equals, a vertical line will follow the form x equals 4. Because it doesn't matter what y is, x is always 4. Remember, a line is a description. The line is a description of the relationship between 2 variables. There is no relationship here. It doesn't matter what y is, x is 4. Sorry for the interruption, probably about a bus route.
Ms. Gates, can you please come to the meeting office if you're still in the building, Ms. Gates?
All right, so which graph represents the line y equals 1/3 x minus 2? So we know that b equals -2 and m equals 1/3. Remember, if you remember your slope man, right, you got undefined slope is a vertical line, negative slope goes down, positive slope goes up, 0 slope is horizontal. So this slope is positive, so we know we have a line going up. So that equation's right out. We also know the y-intercept is -2, so it's going to be one of these 2 lines. That line is out. And then we just have to do the slope. Remember, slope is rise over run, or as I like to misspell it, rise over run. So remember, that's the y. And so the slope of this line is rise 1, 2, 3, run 1. So this has a slope of 3. We're looking for a slope of 1/3, which is this one. Rise 1, 1, run 1, 2, 3. So the correct answer is D. For this one, which equation represents the data set in the table? Now, really, since we've already done problems that are finding the line of best fit, you could just put all of this data into the tables. Put this into L1, put this into L2, and find the line of best fit. But if you wanted to do it without the calculator, look at this point here. That's the point 0, 2. Remember, that's on the y-axis, so the y-intercept has to be 2. So right away, I know I'm down to those two problems. After this, it's a matter of finding the slope. Well, m equals y2 minus y1 over x2 minus x1. And so m will be 3 minus 2 over 0 minus 3. I'm sorry, over 3 minus 0. My apologies. 3 minus 0. And so that gives me a slope of 1/3. Don't get confused, you're busy. But this is x over 3. Remember that x over 3 is the same as 1/3 times x. Those are algebraically the same. All right. Which line represents new problem? Oh, new section. So now we're into section 6, graphing linear inequalities. So we graph a linear inequality the same as we graph a line, with the exception of we either going to shade up or down, and the line will either be dotted or solid. Remember, when we draw the line, we have to make that decision. So this is going to be a solid line, a y-intercept of -5, 1, 2, 3, 4, and a slope of 4/3. So we're going to rise up 4, 1, 2, 3, 4, and run 3. And there's my line. Now, I have to either shade above or below. Well, remember that the alligator eats the bigger thing, so the alligator is eating the y. The y is bigger, so we will shade above the line. People get confused about what's above or below because they see left, right, not up, down. And the easy way to remember what above is put your pen on the line and go up. And that's the half you shade. Oh, we have another interruption.
This state you needed in room 1117. The state, please report to room 1117.
So once again, if we are graphing x equals -4, we would graph that line. However, this is not less than or equal to, it's just less than, so I really need this to be a dotted line. The dotted line means it's a boundary, but it's not part of the solution. And x is less than. So if you go this way, x's are getting bigger. So if we go this way, x's are getting smaller. And there's your graph. For C, once again, slope is -1, y-intercept is 2. Dotted line, because y is less than, and since y is less than, we're shading down. All right, y is greater than or equal to 3. So there's y is equal to 3. Oh, sorry, this is y is less than or equal to 3. So y is less than, so we shade down. The graph the inequality below and then circle all ordered pairs that are solutions to the inequality. So slope is 1/2, y-intercept is -1. It is a solid line because it is less than or equal to. And then I'm going to shade up. So anything in the shaded region or on the line is a solution because it is greater than or equal to. If it was a dotted line, stuff on the dotted line is not a solution. So let's plot these points. 4, 1 is on the line. It's a solid line, so that is a solution. 2, negative 2, 5, oh, sorry, it's actually there, is not in the shaded region. That is not a solution. 0, 1 is right there. That is in the shaded region. That is the solution. This problem is trying to ask the same thing. Unfortunately, this line's not in the right place for this equation, so we're going to skip this problem. But it's the same thing. If something was in the region, it's a solution. If something is on the dotted line, it's not a solution because this line is dotted. So if something had been on the dotted line, it would not be a solution. Unfortunately, this line is not correct, so we're going to skip the answers on this problem. All right, now we're into section 7, graphing linear equations. So once again, same thing we've been doing. Slope is negative 5 over 2. Y-intercept, so I don't know why that plus is there, is 0. So this is a direct variation going through the origin. Slope says go down 5 and over 2. Remember that slope is a pattern that repeats again and again and again. Ooh, that's an awful line. I do not approve of that line. We are going to undo that. And I am going to get a straight line. Like that. For this one, the slope is 0 and the y-intercept is negative 1. Remember, if you have y equals, it's just a horizontal line. For this one, it's not set up. Remember, slope-intercept form is y equals mx plus b. So what I need to do is solve this equation for y. And then depending on how you were taught, you would either think about subtracting 4x from both sides, or some of you may have learned that if you move a term from one side to the other side, it becomes the opposite. Either way, you'd get that. Now, this still doesn't say y equals, so I need to divide both sides by negative 2. And I'll get y equals 2x minus 3. So what that means is that my slope is 2, my y-intercept is negative 3.
Ms. Shopreda, you need it in the counseling office. Ms. Shopreda, you need it in the counseling office.
Now, you can change slope into a fraction, any whole number in a fraction, by writing it over 1. Once again, slope is a pattern that repeats. And so there is my graph line. All right, so this one they ask for the slope of the line. So once again, I want to get y equals whatever I get, and whatever's in front of the x will be the slope. So I'm going to subtract 1/5 from both sides, and I'll get negative 4y equals negative 1/5 x plus 6. And then I'm going to divide both sides by negative 4. And this will be y equals 1/20 x minus 3/2. And so my slope is 1 over 20. For this next one, it's asking what is the slope of the line below. Now, so we're going to pick 2 points on the line. It doesn't matter what 2 points you pick. Just pick somewhere where it crosses through a corner or an intersection. Oh, didn't mean to do that, but we can put it all back. In between any of those points, we just look at the rise. We go down, so that's negative 1, and we go over 2. So the slope is negative 1/2. If you pick points further apart, like here, I'm going to do this in red. There, it's negative 2 over 4, but if you reduce that fraction, it's still negative 1/2. So here, this problem F is almost exactly like D. Subtract 5x from both sides, and I'll get negative 2y equals negative 5x plus 12. Then we're going to divide both sides by negative 2. And I'll get y equals 5x 5/2 x, sorry, minus 6. So the slope is 5/2. Convert the equation below to slope-intercept form. Same type of problem we were just doing. Subtract 4x from both sides. I'll get 3y equals negative 4x plus 20. Divide both sides by 3. And I'll get y equals negative 4/3 x plus 20/3. Which if you really want it, or which is also 6 and 2/3. No, that's not right. Yeah, that's right, 6 and 2/3. But you can leave it as a fraction, or you can change it to this, or if you wanted to, you can write it like that as well. All of those are the same. Most likely on the test, the b will be an integer, so that it make it easier for you to graph. Convert the equation below to slope-intercept form. Once again, same process. Subtract the x from both sides, and then divide both sides by the coefficient of y. And so this will be y equals 1/3 x minus 1. And now we're in slope-intercept form. So that is it for the section on graphing linear equations. We still have one more section to go, which is the flashback questions. Once again, the link to the graphs will be in the comment sections below.